Hello everyone, and welcome to A1 Tutor live class. Welcome to A1 Tutor live class. And now we're going to be having our mathematics session for today. Last class in our mathematics class, we started a topic which is set theory, sets. We started the topic sets, and we're able to deal with the terminologies in sets. We're able to define and discuss and explain each of those terms that are used in sets. Okay, we started with what a set is. Then after we went to the definition of a universal set. We discussed what a singleted set is. We discussed what a union is between two given sets, an intersection between two given sets. We also made mention of cardinality. We also made mention of cardinality of a set. So all of this we've discussed in the previous class. Okay, so if perhaps you are not able to join the previous class, I will urge you to visit our YouTube channel to watch the previous class. So today will be the continuation of our previous class. We're going to continue where we stopped in the last class. All right. So today we are going to consider the remaining terminologies we have in set theory. Then we are going to take some UTME question. We're going to take some UTME question. Okay, before we start, I want to be rest assured that you can hear me. So if you can hear me, kindly signify with your emoji or say yes. Type yes in the chat box. Can you hear me? If you can hear me, please kindly signify. If you are online and you can hear me, please kindly signify so that we can proceed to today's business. If you can hear me and you can see the screen, please kindly signify. I'm waiting for your reaction so we can kickstart properly. All right, thank you, Miriam. Thank you, Lani, Miriam. Okay, so let's continue from where we stopped. A recap again, we talked about sets and we said set is the collection of a well-defined object, a well-defined object. So we said, okay, let's say we are asked to list out the days in the weeks. The days in the weeks are 7 in number, and that is a well-defined object because it's talking about the days in the week. So we don't have a mixture of probably days and months together, but just the days of the week is a well-defined object. So the collection of those days is said to be a set. Okay, the alphabet in English language, if you are asked to have a list of vowels in English language, that is A, E, I, O, U. That also is a well-defined object and is also a what? A set. So these are the things we discussed in the last class. So today we are going to consider the next aspects, the remaining aspects of those terminologies we are defining. And we're going to consider first what we call a finite set, a finite set. So as the name implies, finite. When you hear the word finite, literally meaning it means something that can be counted, something that is countable, all right? So a finite set is a set that is countable. A finite set is a set that its elements can be counted. Its elements can be what? Counted. So a set that the elements in that set can be counted numerically is said to be a finite set. Okay. So let's consider this and see if this is countable. We have a given set A equals to A, E, I, O, then U. So this is a given set. Now, can we count these elements? The elements are each members in the set. So this is an element, E is an element, I is an element, O is an element, and U is an element. So if you can count it, that means it is a finite set. So in this case, we have 5 elements. So it's countable. 5 elements. So this is what countable. That means it is a finite set. It is a what? A finite set. A set that its element can be counted is said to be a what? A finite set. So what about an infinite set? An infinite set will be the opposite of a finite set. An infinite set will be the what? The opposite of a finite set. So let's consider infinite. An infinite set is a set that its element is uncountable. Its element is a what? Uncountable. So a set that has its element to be uncountable is said to be what? An infinite set. That is, we cannot count the elements in that set. We cannot count the elements in that set. And a very good example has to do with our numbers in mathematics, all right? So if I said a set of natural numbers, okay, let's say A is a given set, A is a given set, and is X such that X is a natural number. A is a set such that X is a natural number. So in mathematics, natural number starts from 0. So we are saying we want to have a count of all the numbers we have in this life. So you know that is not what? Is not countable. Okay, so if I pick it from 0, 1, 2, 3 up to 1 million, we still have values after 1 million. We have billion, we have trillion. After trillion, we still have another value again. So natural numbers are not countable. They are too much. They are numerics. We have a voluminous numbers in mathematics that we deal with. So natural numbers are not what? Are not countable. So it's a good example of what? Of infinite set. Okay, what about integers? Integers in this a set that has to do with numbers that are integers. Integers are both negative and positive, or negative and positive whole numbers, right? Integers, they are both positive and negative whole numbers. So if you are asked to list out the integers we have, you will see that we have a lot of integers. We have minus 1 trillion is an integer because it's negative integer. We have trillion. After trillion, we still have other values. So integers are also many. So they are also classified as what? Infinite set. They also classify as what? Infinite set. Okay, so that is the definition and the explanation to what a finite set is and what an infinite set is. All right, so I believe that is clear to us. Can we proceed? If we can proceed, please kindly thumbs up so that we'll move on to the next. I need your reaction so I can move on to the next. If you understand what a finite set is and an infinite set is, kindly thumbs up so we move on to the next. Okay, Naima, okay. That means we can proceed, right? So let's move on to the next now. So we've defined what a finite set is and what an infinite set is. Now we'll proceed to a disjoint set. So permit me to clean the board. Permit me to clean the board. So we'll proceed to the next. Still on sets, now I want to discuss a disjoint set. A disjoint set. So what is a disjoint set? Two sets, two sets, two sets given A and B are said to be disjoint, are said to be a disjoint set if they have no elements in common, if and only if they have no elements in common. Two sets, A and B, are said to be disjoint sets if only if they have no elements in common. So when we have two given sets A and set B, set A is 1, 2, 3, and set B is 6, 8, 9. And we are asked to determine whether this set is disjoint or not. We have to check if they have common elements. Is there an element that we have in A that is also showing in what? In B. So when you consider this illustration or this example, we see that all the elements in A cannot be found in B, and all the elements in B cannot be found in A. So in that case, A intersection B is going to be an empty set. That is a set that contains no elements, is an empty set. So they have no elements. What I call elements are the members. We said it earlier in our previous class. These are called elements. The members in each set are called what? Elements. So if you check the two sets, you will see that there's no element that can be found in both sets. So in that case, we say that sets A and B are what? Disjoints. They are not joints. That's why I have the word disjoints. Okay, so they have no element in common. And mostly, a disjoint set is always equals to an empty set because we have no common elements in it. Okay, I believe that is clear. So if I may ask that if I have X to be a given set, which is 1, 2, and I have Y to be a given set, which is 3, is set X and Y disjoint? That is my question. Is X and Y a disjoint set? Is X and Y a disjoint set? I want your reply in the chat box. Is X and Y a disjoint set? I'm waiting for your reply in the chat box. So your answers will either be yes or no. Is X and Y a disjoint set? We said a disjoint set is a set that have no element in common. So you have to check set X and Y and determine if they are disjoint or not. This set X and Y. So I'm waiting for your response in the chat box so we can proceed. Any response? Is set X and Y a disjoint set? Yes or no? Okay, if you look at it together, you will see that the elements we have in X are not found in Y, and also the elements we have in Y are not found in X. Therefore, they are what? They are considered, they are disjoints. They are what? Disjoint set. So set X and Y are what? Disjoint set because they have no common elements. They have no common elements. So let's move on to the next terminology. Okay, let's move on to the next one. So permit me to clean the board. We want to consider the next one, which is non-disjoints. Non-disjoints. The next one is non-disjoints sets. So of course, this is going to be the opposite of a what? A disjoint set. This will be the opposite of a disjoint set. So two sets, let's say A and B, are said to be a non-disjoint set, are said to be a non-disjoint set, are said to be a non-disjoint set when they have at least one common element. When they have at least one common element. At least one common element. Two sets A and B are said to be disjoint, are said to be non-disjoint sets when they have at least one common element. One common element, which implies that the common element can be more than one. That's the meaning of at least. So we have at least one. That means we can have one common element, two common elements, three common elements, four or five, and so on and so forth. So let's say we have set A, set B, and set A is A, B, C, and set B is D, E, C. So when you check these two given sets, you discover that we have a common element. C is in set A, and also C is in what? In set B, which implies that both sets are what? Non-disjoints. Non-disjoints. Because they have one common element, at least one common element was existing. And that implies that if you have to take the intersection of A and B, intersection means the common elements in two given sets, in two or more given sets. And the common elements here is what? C. We have C here, we have C here. So we have C to be what? The common element. So in a non-disjoint set, we always have an element that will be present. That is, an element will be present in the intersection of those two sets. So you can see that A intersection B will have C. But if it was disjoint, A intersection B will be empty sets. But in this case, we are going to have an element to be inside the what? The curly brackets. Okay, so if I decide to have the question in this form, x, y, x is given as 1, 2, 3, 4, and y is given as 2, 4, 5. So if I take x intersection y, that's the common element. 2 is common to both sides. We have 2, comma. 4 is common to both sides. We have 4, and we close the what? The curly brackets. We have 4, then we close the curly brackets. So you can see that in this case now we have two elements inside their intersection. So it is not always going to be 1. It can be 1, it can be 2, it can be more than 2, more than 3. But the fact is that they have some elements that are in common. Some elements are common to both sets. So this illustration also here, x and y are also what? Disjoints. They are non-disjoints. X and y is considered to be non-disjoints. X and y is considered to be what? Non-disjoints, because they have some elements in common. Okay, I believe that is clear. So can we proceed? Can we proceed? If you can proceed, please, thumbs up. Signify with your emoji. All right. So let's proceed to the next thing. I believe this is clear to us. What is the difference between a disjoint set and a non-disjoint set? A disjoint set is a set that have no elements in common. A non-disjoint set is a set that has some elements in common. All right. So now let's move on to range. This part we want to take is very important, because if you do not understand range, when you are solving question on sets, you'll find it so difficult to interpret your question. So range. The next thing we are going to consider is range. And to explain this, we are going to be taking some illustration on it. We are asked to list some activities, list the elements, list the elements of the following set below, of the following set below. So the first one was given as L equals to the curly brackets y such that 16 is less than y less or equals to 19. Less or equals to 19. Close the curly brackets. So this is what we call range. You will barely see some question where they will be giving you all the elements at once. They will always denote your elements in range form. So you'll be the one to interpret and list out the elements. So if your interpretations are not accurate, you are likely to get a response that is not also accurate. So you need to understand range. And if you look at this question, we have what we call the inequality sign. We have the inequality sign. So also you have to relate to your knowledge of inequality to get this done. Okay, to get this done. So if I'm going to do this, let's say we have y, they said y, L equals to y such that 16 is less than y, less or equals to what? Less or equals to 19. So we are dealing with values that falls within this range that was given to us. We want to write out the values or the list of elements that falls within this range. 16 is less than y, less or equals to what? 19. So which implies that less than, less than or equals to. We call this one a weak inequality sign, weak, while we call this a strict or strong inequality sign, strict or strong inequality sign. Okay, so when you have this sign, which is a weak inequality sign, you have to know that when you are writing your elements out, the 16 should not appear as part of your element because the 16 is being connected to a weak inequality sign. Okay, which means the element they're asking us to write should be elements that are less than y when y is less than or equals to 19. Are you getting that? So if I'm going to write out the elements, because 16 is connected to a weak inequality sign, 16 will not be part of the element I want to write. So what are other numbers less than 19? Okay, let's write it out. We have 17, 18, 19. These are the numbers less than what? 19. All right. Now, the reason why I didn't include 16 is because we have less than 16, and it is not less than or equals to. If it is less than or equals to, I'm going to include 16 inside my what list. Okay. So the numbers that are less than or equals to 19 are these numbers following the what? The condition that 16 is less than those number which are what? Y. 16 is less than. So that y has to capture the values that are just within the range of 17 to what? 19. Now, the reason why we include 19 is because we have less than or equals to, less than or equals to. So the element will be 17, 18, and 19. Because we have less than or equals to, that's why we included 19. But for this case, we have less than. So 16 will not be included in those numbers. 16 will not be included in those numbers. So these are the what? The elements in what? The given range. These are the elements in the given range. Okay? I believe that is clear. If that is clear to us, can we proceed? I believe that is clear to us. So can we proceed now? Okay, so I have a question for us. What will be the elements in this question? Okay, I will need to explain for the sake of one of us asking for a question. We have 16 less than y less or equals to 19. All right, and we are asked to write the elements in this range. Y such that y is 16 less than y less or equals to 19. Now, let's use what we call the number line. We have 16, 17, 18, 19. All right, let me say 20. Okay, now if I'm going to use this, I want to express this on a number line. I want to express this on a number line. Okay, so we have 16 less than y less or equals to what? 19. Okay, for inequality, when you have a less than or equals to x less or equals to b, we can represent that on a number line, right? Where is 16? We have 16 here. So let's give a circle here. We identify 16. And again, we need to identify the other number, which is what? 19. We're identifying 19. Is that taken? Okay. So I will draw a line to connect both of them. I believe that is clear to us. Okay. So what do we do? You have to check the inequality sign. This place is just ordinary less than. So on 16, I'm not going to shade the what? The circle, because it's just less than. But on this case, it is less than or equals to. So I need to shade. So when you are shading this, it means that you must include 19 as part of the numbers you'll be writing out in your what? Elements. You must include 19. So if I do not shade 16, I'm not going to include 16. So I'm going to start from 17, 18, 19. I'm writing 19 because it is less than or equals to 19. So the elements here will be 17, 18, and also what? 19. Okay? I will not include 16 because it is less than. We don't have, it is ordinary less than. It does not have any other sign that says it is equals to 16. So we ignore 16 and we'll move on with 17, 18, then 19, because 19 has less than or equals to 19. Is that taken? So Naima, I believe it's clear now. So can we proceed now? Naima, can we proceed? So can we proceed to the next one? I'm waiting for your response. Can we proceed to the next one? Waiting. Naima, can we proceed to the next one? Just react, give us a reaction. Naima, can we proceed now to the next one? Okay, so I believe we can proceed to the next question. So we have another range again to consider. We have question 2, n such that the set B n equals to the set B such that 3 is less than or equals to B less or equals to 6. And we are asked to write the elements of this set. We are asked to write what? The elements of this set. So we can still make use of number line so you can understand better. Okay, we have, let's say, let me start from 1, 2, 3, 4, 5, 6. Just let me include 7. So what we have to do to know the elements, indicate, locate where you have 3 on your number line. We have 3, this is 3. And locate where you have what? 6 on your number line. This is what? 6. So draw a line to connect them together. Now you have to come and consider the inequality sign that you have. This is less than or equals to. That means I have to shade this. And also this is less than or equals to. That means I have to shade this. So shading it means I'm going to include 3 and 6 as part of the numbers I'll be writing out as my elements. So the element is 3, 4, 5, 6. So the element will be 3, 4, 5, and what? 6. The elements will be these values we have in the curly brackets. All right. So this will be the elements we have for set n, for the given set what? N. So I believe that is clear. Can we proceed? We want to move on to some questions. We want to apply all we've defined earlier. Those terms we have in set, we want to apply them to some questions now. So can we move on to that? Can we proceed to the next questions? If I'm waiting for your response. If you think we can go on with the next question, please thumbs up so that we'll move on to the next question. Kindly react if you want us to proceed to the next question that we have. I'm waiting for your reaction so that we can move on to the next question. Okay, so now let's proceed. We are going to consider some UTME question, and I want us to be very attentive and stay connected while I'm trying to make a justice to that question. So stay connected and be very attentive. Let's consider the first application. Okay, the first application, which is a UTME question. We are given a question from UTME 2024, and we are given P as a set, which is 1, 2, UV, comma, W, X. All right, and we have another set Q, which is equals to 2, 3, UV, comma, W, 5, 6, and we have Y, close the curly brackets, and we have R equals to, open the curly bracket, 2, 3, 4, V, X, and Y, close the curly brackets. And what we are asked to evaluate is to determine P minus Q intersection R. P minus Q intersection R. Okay, so we are going to solve this together. The first thing we have to do is to break down the question. P minus Q is what we should go for first. Let's solve for P minus Q. It's just like in the normal subtraction we're doing in mathematics. If you have 3, you have 2. You are taking away 2 from 3. So I'm taking away Q from P. Okay? So what I'm going to do is that I will consider these two sets. I'll consider these two sets. Then I'm going to be removing the values or the elements that are in Q from P. The elements that are in Q from P. Okay, so if that's the case, let me use another ink. Let's use this. We have 2 here, all right? We have 2 here. So subtracting it from Q, it means cancel 2. So 2 is out of it. What we are left with is what we have inside the element. Let's go on again. 3, of course, we don't have 3, but we have U. So we cancel out U. U is out of it also. We have V. We cancel out V. V is out of it also. We have W. We cancel out W. W is out of it. So what you notice is that we are left with just 2 elements in P. After the subtraction has taken place, we are left with 2 elements. That is 1 and what? X. We are left with what? 1 and X. 1 and X. All right? So that means subtracting Q from P, the answer is 1, X. 1, X. After we've subtracted the elements that are in Q from the ones in P, what was left in P was 1, X. I believe that is clear. If it is clear, thumbs up before we continue the solution. Thumbs up, thumbs up, thumbs up. We are not yet done, but I want to be sure it's clear so that we can proceed. Okay, it's clear to us. So let's go on now. We've gotten Q minus P. So now we want to get the remaining one. Now let's get P minus Q, which we have done before. Now intersection R. Intersection R. Okay? So all you need to do is to compare the answer for this with the elements in what R. And intersection means common elements in 2 given sets. Common elements in 2 given sets. So if I write this, Q minus P is 1, X intersection. Now let's write the elements of R. We have 2, 3, 4, V, X, Y. Okay, the final answer, we are trying to get the intersection between both of them. So let's check both sides. Let's check both sides. What are the common elements? We have 1 here, but we don't have 1 in R. Okay, but we have X here. We also have X here. So X is what? Common. X is common to both sides. X is common to both sides. Okay, so if X is common to both sides, that means we have the answer to be what? X. The common element between this P minus Q and R is what? X. So the final answer for that UTME question is going to be what? X. The only element that is common to both of them will be what? X. I believe that is clear. If it is clear, please thumbs up. Okay. So let's move on to the next one. Now, I want to ask a question quickly based on this. A set that has only 1 element is called what? A set that has only 1 element is called what? You can drop your response in the chat box. We've discussed it in the previous class in case you are not part of the class. But if you are part of the class, a set that has only 1 element is called what? Because we have only 1 element in this set. The response is going to be a singleted set. A singleted set is a set that has only 1 element. So please take note for the sake of CBT exams, okay? A set that has only 1 element is called a singleted set. Is that taken? So let's move on to the second application. We'll proceed to the second application. So I'm going to clean the board up to. Okay. The second question we want to consider is this. If P, UTME question, okay, UTME question 2014, if P is given as 1, 2, 3, 4, 5, And we have P union Q to be equals to 1, comma 2, 3, 4, 5, 6, 7. And that lists the elements, in Q. List the elements in what? Q. We have this given question to solve. We are given P to be equals to this if P is equals to this, and P union Q is equals to this. List the elements in Q. So they want us to get the elements that are in what? Set Q. Okay? And union means the combination or the joining of two given sets. Union means the combination or the joining of two given sets. Okay? So if I'm given already the union, this is the union. Okay? So I want to get Q. That means this P has been added to Q, has been joined together, The union have taken place between P and Q for us to get this expression. Now, if I want to get Q, that means I'm going to take away P from the union. When I take away P from the union, the remaining elements are the element of what? Q. Okay? The remaining elements are the element of what? Q. So let's write Q as an element, as a set now. Now let's take away the elements that we have in P from their union. We have 1 in P. Take away 1. Okay? We have 2 in P. Take away 2. Okay? We have 3 in P. Take away what? 3. We have 4 in P. Take away 4. We have 5 in P. Take away 5. So what is left? We are left with 2 values, which is what? 6 and 7. That means 6 and 7 belongs to what? Set Q. That means 6 and 7 belongs to what? Set Q. So set Q is 6, 7. Set Q is what? 6, 7. I believe that's clear. If it is clear to us, please let's have a reaction. All right. Thank you for your response. Okay. So thank you for your response. So that is some question we've solved so far. We've solved 2 questions, all right? So I want to give us one evaluation question. I want to ask us to give me the response to this. If I have X to be a given set, okay, if X is a given set, let's manage this space. X is a given set such that n squared plus 1 such that n is equals to 0, 2, 3. Okay, we are asked to write out the elements in what? X. We are asked to write out the elements in X. So what will be the first element for this question? You can type your response in the chat box very quickly. What will be the first element here? Okay, I will help us with the first one. We have n squared plus 1 such that n is equal to 0, 2, 3. So we have to simplify this expression to get the element we want to write out. N squared plus 1. When n equals to 0, it means 0 squared plus 1, which is what? 1. So the first element is what? 1. So what will be the second element? I'm waiting for your response in the chat box. What will be the second element? What will be the second element? I've done the first one. What will be the second element in X? You just have to replace these values into this expression, solve it, and your final answer will be the elements. So I'm waiting, what will be the second element? When n was equals to 0, we said 0 squared plus 1, changing this n to 0. Now, if n equals to 2, what's going to be your value? That will be 2 squared plus 1. That is 2 squared is 4. 4 plus 1 equals to 5. So the next one is what? 5. So I leave the next one to you. What will be the next element when it is 3? When n equals to 3, what will be the next element? Waiting for your response. Just type your response in the chat box. What will be the next element, the last element, when n equals to 3? You can type your response in the chat box. What will be the element when n equals to 3? All right, that is going to be 3 squared plus 1. That is 9 plus 1, and that is 10. So the next element will be what? 10. The next element will be 10. So we are going to stop here today, and we continue the topic tomorrow. We continue the topic tomorrow. So please, if you've missed the first class on sets, kindly refer yourself back to the YouTube channel, check for A1 Tutor, and watch the first class on sets. This is the second class, and tomorrow we'll continue with the third class for the continuation of the topic. Okay, for the continuation of the topic. And tomorrow we are going to have more applications to solve, tomorrow. And we are going to consider the latter part of the topic, which is what? Venn diagram. Venn diagram and the applications of what? Venn diagram. Okay? We are going to have another class in the next few minutes, so please stay online and join the physics class so that you are not going to mix anything valuable for your preparation to this UTME exam. Is that taken? So if you are with me and you enjoy the class today, please thumbs up, and we'll meet in some minutes later. All right, thank you. Stay online. We'll meet in few minutes time